Hello, this video is going to give you an introduction into the real Taylor or RT curve, which is an integral part of our short-run equilibrium model. Now let's recall from a previous chapter, chapter 11, we learned about the Taylor rule. The Taylor rule helps us understand how monetary policy is determined, how the central bank sets interest rates. We learned that the central bank must set the interest rate in a way that links to some natural rate of interest, a concept that we learned in a previous chapter, and the expected rate of inflation. We also learned about the idea of inflation targeting. So if the rate of inflation exceeds the target, the central bank needs to choke off some demand in order to bring back the inflation rate to its target. If the inflation rate is under its target, the central bank needs to lower the interest rate, once again in order to stimulate demand and bring the inflation rate back to its target. We also remember that the central bank has part of its mandate to keep output as close to potential as possible. Remember that it's worried about employment. If output is less than potential and the output gap is negative, the central bank needs to lower interest rates. If the output gap is positive and our output is above its potential, we're straining the capacity of the economy. We're running the risk that the economy is going to overheat, so we need to raise the interest rate once again in order to bring down, to discourage demand. And finally, we learned that the central bank needs to have a margin of discretion for some of the challenges that are on the horizon, the challenges to price stability and output stability. We also learned about the Phillips curve in previous chapters. The Phillips curve told us that the observed inflation rate is linked to, first of all, the expectations that market participants have of the inflation rate, plus some factor related to demand minus supply, the output gap, relative to any shifts or shocks in the short-run aggregate supply curve. So this tells us that inflation will rise if either expected inflation rises or if the output gap rises relative to some short-run aggregate supply shock. Now, in order to help us further develop our model of short-run macroeconomic equilibria, it will be useful to combine the Taylor rule and the Phillips curve into one equation. In reality, this is a natural thing to do. Why? Because the Phillips curve is a constraint for the central bank. Well, what does that mean? Well, recall from the previous chapter that two key elements of aggregate demand are determined by the real interest rate, consumption and investment. Thus, if the central bank wants to reduce inflation, it either has to reduce expected inflation or it has to reduce the output gap from the demand side. And that's precisely what the Phillips curve already has told us. So we're going to employ a common economic modeling technique. If one equation is in a constraint for the other, we're going to combine them, and we're going to see how this happens on the next slide. So once again, here is the Taylor rule. Here's the Phillips curve. You'll see inflation here. What we're going to do is we're going to take out the inflation rate and we're going to substitute in all of these other elements, expected inflation and the relationship, the output gap minus shocks to the short-run aggregate supply curve multiplied by 1 over the elasticity of short-run aggregate supply with respect to the price level. And what are we going to get? We're going to get a relationship where the output gap is positive related to nominal interest rates. The idea here is we haven't taken inflation out. Instead, inflation appears now indirectly into the Taylor rule, and the idea is that there's two reasons why the central bank will raise the interest rate when the output gap. One direct reason that we learned on the previous slide is its goal of output stabilization. But then the other reason, which is the indirect reason, is its objective of keeping inflation on target. So one next step that we go into in greater detail in the book is we subtract off the inflation rate on both left-hand side and right-hand side of our equations, and that allows us to express the Taylor rule in terms of the real rather than the nominal interest rate. So you're going to see here on the vertical axis the real interest rate, and you're going to see here the output gap in percent of potential output. This solid blue line, this is the RT curve for expected inflation fixed, short-run aggregate supply shocks, PBS fixed, and also no discretionary element. So we can see that this solid blue line slopes upward. It tells us that when all else equal, when the output gap rises, the central bank needs to raise the interest rate in real terms. This curve will shift to the left from the solid blue line to the dashed blue line in the event of an adverse supply shock, or in the event of an increase in inflationary expectations, or in the event of a discretionary tightening. So when this curve shifts to the left, that means that for any output gap, the interest rate that the central bank will set is now higher. In the other direction, we'll have a shift of the RT curve to the right in the event of a favorable supply shock, if there's a decrease in inflationary expectations, or if there's a discretionary loosening. So what that means is that when this shifts to the right, to the blue dotted line, for any value of the output gap, the real interest rate set by the central bank will now be lower. Now, everything that we just told you is true if the zero lower bound does not constrain. But now we have to look at the case where the zero lower bound does constrain. Now, this typically occurs when economic activity is in an extreme downturn. And as we're going to see, if the zero lower bound constrains, the RT curve is not going to slope upward. In fact, it's going to slope downward. Now, why is that? Well, let's suppose that the output gap goes down. If the output gap goes down, the inflation rate will go down. Now, at the same time, the nominal interest rate would normally go down, but if we're up against the zero lower bound, the nominal interest rate is effectively going to be stuck at zero, or at some value close to zero. So now you'll remember that the real interest rate is equal to the nominal interest rate minus the inflation rate, approximately. So if the inflation rate goes down, but we're stuck at the zero lower bound, the real interest rate goes up. So you can imagine that this is actually a very perverse, or as some people have called it, a topsy-turvy dynamic. As the output decreases, the real interest rate rises, and this is going to choke off demand even further. So here's a more complete picture of the Taylor rule, the real Taylor rule, the RT curve. Over on the right, to the right of this blue line, we can see that the real Taylor rule is sloping upwards. This is the territory where the zero lower bound does not constrain. And we have some math in here. If you're interested in knowing how to compute the slope of the real Taylor rule, we have some details in the book. Over here, this is zero lower bound territory. This is the territory where the nominal interest rate just can't get any lower, but when the output gap falls, inflation falls, the real interest rate rises. Now, if you're interested in knowing why we have this curve, I would recommend that you look at some of our other learning aids. We have a spreadsheet and an associated video that will show you exactly why we get the shape of the RT curve. And then, for those of you who are a little bit more algebraically oriented and you want to get a rain or shine equation for the RT curve, you can see that in the Where Did We Get Those Numbers feature in the book.